Hello and welcome back. In this video, we'll be looking at limits via graphs. And I want to start out quite slow. So let's look at this first sequence here. We've got some numbers. We've got 0.9, 0.99, 0.999, 0.99999, so on and so forth. This sequence is getting closer and closer to 1. All these numbers are quite close to 1 already. But we can see that they're getting even closer and closer and closer to 1. So this is what we call approaching 1. If something approaches something else, it means that it's getting closer. So this is all we mean here. For instance, and then again here, if we have 0.1, 0.01, 0.001, 0.0001, so on, you can see that these numbers are also getting closer and closer to 1. The only difference between these two sequences is what direction we're approaching 1 from. So for instance, this top sequence, we're starting at 0.9, which would be about here on our number line, and then 0.99, 0.999, and you can see that we're getting closer and closer to 1 from the left-hand side. This bottom sequence, on the other hand, we're starting at 1.1, maybe about right there, and then 1.01, 1.001, 1.0001, and again, we're starting from the right-hand side, and we're getting closer and closer to 1. So these sequences are approaching 1, but from opposite sides. And we have a little bit of terminology for this. So we'll use this arrow here to mean approaches. So if I write x arrow A, this means that x is approaching A. But I haven't clarified if we're approaching from the left or from the right. Technically, this means from both directions at once. So this, let me write this in red. So this is from both directions. And if we want to clarify one direction or the other, we add this little negative sign or this plus sign, and these go up here. They kind of look like exponents. They're not really exponents. This is just where we write them so we don't get confused. So as x approaches A from the negative side, meaning from the left side, and then this one means x is approaching A from the right side, from the more positive side. So positive numbers to the right, negative numbers to the left. This is all this means. If we were given a function, let's say 3x plus 2, and we take our numbers that are approaching 1 and we plug them in. So if I plug 0.9 into this function, I get 4.7. If I plug 0.99 in, I get 4.97. 0.999, 4.997. We can see that these numbers are getting closer and closer to 5. And likewise, if I start approaching from the right-hand side, if I start plugging in 1.1, I get 5.3. And then I'll get a 5.03, 5.003. These numbers are also getting closer and closer to 5. And we can see that as we approach x from the left-hand side, so using numbers, as x approaches 1 from the left-hand side, so we plug in numbers like 0.9, 0.99, 0.999, our function is getting close to 5. And as x approaches 1 from the right-hand side, we're plugging in numbers getting closer and closer to 1 from the right-hand side. Again, we're approaching 5. And these are called limits. So this I think entire chapter is going to be about limits, and limits are going to be the motivation for pretty much everything. So let's look at this visually. So we have our graph of f of x is equal to 3x plus 2. Again, this is a straight line, mx plus b. The slope's 3, so go over 1 up 3, over 1 up 3, and our y-intercept is 2, so we're going to cross here at 2. So what this means, what all this means is if we plug in an x that is 0.9, we're plugging in an x that's right here. And we see that this is the dot that's going to represent where where we are on this graph. If I plug in a number that's even closer to 1, you can see that we're getting closer and closer to this dot up here. So if I sort of erase these, as we get closer and closer to 1 from the left-hand side, say we're coming from the left-hand side, we are getting closer and closer to this point up here. Also, if we approach from the right-hand side, I'll use blue for this side. If we approach from the right-hand side, if we are starting from more positive numbers and getting closer to 1 from the right-hand side, as we plug these into our function, we're going to see that we're coming down this line and we're getting closer and closer again to this point right there. So we have some notation for this. We write the limit as x approaches a from the left-hand side of f of x. So again, the limit as x approaches a from specifically the left-hand side of f of x. And when we do this, so we'll keep this in red, so the limit as x approaches 1 from the left-hand side of f of x, and we can see that we're getting closer and closer. The function value, as we plug in x's that are closer to 1, we will get 5. Likewise, we can talk about limits from the right-hand side. So the limit of the limit as x approaches a from the right of f of x, and we can see that as we plugged in values that were bigger than 1 but getting closer and closer to 1, the limit as x approached 1 from the right-hand side of f of x was also equal to 5. And then we can say just the limit as x approaches a of f of x. And again, without this symbol here, without the plus or minus sign, this means that we're technically going to be approaching from both sides simultaneously. And we can see that in this diagram, it doesn't matter what side we're approaching from. In our function, we always are approaching 5. So the limit as x approaches 1 from both the right and the left-hand side is equal to 5. So it doesn't matter which side we're coming from. And again, this limit, when I write this without a plus or minus sign there, it means from both sides at the same time. So if I want a limit to exist, we had better approach the same place from the left and right-hand side. So let me go through an example where this might not exist. So we have the following function. Our function is going to be equal to 3 whenever x is less than 2, and it's going to be equal to x whenever x is greater than or equal to 2. Okay, so the function fx is equal to 3. Well, that's just going to be a constant height the whole time. The y value is just always going to be equal to 3. And where 3, whenever x is less than whenever x is less than 2. So here's x is equal to 2, so if we come up to that point, we're going to draw an empty circle because x is less than 2. If x is equal to 2 or bigger than it, we have a different function, a different part of our function. Fx is going to be equal to x. So the line y is equal to x is going to be a straight line. It has slope 1. It's going up and down. And this is going to start when x is equal to 2. So x is equal to 2. And then we're going to continue going up. So this is what our function looks like. Whenever x is less than 2, we just have height equal to 3. Whenever x is greater than or equal to 2, the height is the same as the x value. So at 2, we're 2, at 3, we're at 3, at 4, we're at 4, and so on. So the question is, what is the limit of f of x as x approaches 2 from the left-hand side? Well, as we follow our function, let's see here, maybe red is a bit easier to see. As we follow our function from the left-hand side, as we get closer and closer to 2 here, we see that the height of our function is always 3. So we are getting closer and closer and closer to this dot here, which is at 3. If we approach 2 from the right-hand side, however, here's the line. As we get closer and closer to 2, we're coming down here. And as we get closer and closer to 2, we're getting closer and closer to this height, which is also at height 2. So as we come in from the left, we come in a little bit high, and as we come in from the right, we're coming in a little bit lower. So we have a different limit as we come in from the left and from the right. So what this means is that this limit doesn't equal anything. This limit does not exist. Okay. So when we have functions that jump around a little bit, this limit isn't going to exist here, because as we come in from the right-hand side and as we come in from the left-hand side, they're pointing at different places. Maybe one sort of nice way to see this is the following. I can draw a line right here, straight up and down. This line will be in blue. I hope you can see this. And as I'm coming in from the left-hand side, I'll hit this x here, and as I'm coming in from the right-hand side, I'll hit this x here. These x's are going to be our limits. As we come in from the left-hand side, we'll hit the top x. As we're coming in from the right-hand side, we'll hit the bottom x. Left-hand side is a little bit higher at 3, right-hand side is a little bit lower at 2. 3 isn't 2, so our limit doesn't exist. So let me erase a few of these. But just because the limit doesn't exist somewhere, it doesn't mean that it doesn't exist everywhere. So let's look at the function as x approaches 0 from the left and the right. So here is where x is equal to 0. It's going to be right at the y-axis. So again, as we come in from the left-hand side, we're following our function. As we come in from the right-hand side, as we get closer and closer to 0, we're going to be approaching the same spot. As we approach it from the left-hand side, we're following the function, and the function is just going to be 3 everywhere to the left of 0. So as we come in from the left, we're approaching 3. As we come in from the right, we're also approaching 3. So this limit is just 3 as well. So limits, we're just looking at the function value as we come in from the left and the right. What does the function value get close to? Sometimes it gets close to 2 different things. Sometimes it gets close to the same thing. And I think I'll stop here and continue in the next video.